Hey there! In this video, we're going to go over the formal limit properties. Just in case you have one of those teachers or profs who need you to understand limit properties formally, I got you covered. A lot of teachers will do that. They'll throw up these properties and they'll be like, what the heck is this stuff? Allow me to explain. It'll be a quick video, but one that I think will make some sense. So essentially, here are all our limit properties, and it has to do with direct substitution, when we can just substitute in a limit directly. So in a previous video, I went over a bunch of examples like this. These are the formal properties. So this says the limit as x approaches some c value of a constant k, meaning k is some number, 5, -3/2, some fixed number. Then the limit is going to be k. All right, so in numbers, what does that mean? That would be something like the limit as x goes to, I don't know, 2 of 7. Well, that's going to be a limit of 7. That's it. And I actually do an explanation of why that makes sense in a previous video. The limit as x approaches, again, some x value c of any function raised to some power n. That could be 3, 5, 17, -3, something. As long as this number is within this domain, we're good, and really any number will work as long as n is positive. So let's just plug that right on in. So your final answer would be c to the n. That's it. Just showing you can evaluate it. So with numbers, this would be like saying the limit as x approaches -1 of, let's do, I don't know, x to the 3rd power. Well, that would be equal to plugging -1 directly in there, which gives you -1, because -1 keeps -1. That's it. This says the limit as x approaches c of some constant times a function. That's the same as, this is kind of a funky one, k times the limit. And actually, do I want to show this as formula? You know what? I'm going to reverse that one. K times f of c. Right? Essentially what that means, another way of looking at that is k times the limit as x approaches c of f of x, which when you plug in c, you'll get f of c times k. All right, what does all that mean? What that means is, let's say that you get the limit as x approaches, let's do 7 of 2x squared. What this means is we can then look at this as just plugging in 7 and just evaluating the limit of x squared. So that's 49 times 2 is 98. Or you could take it and say it's the same as 2 times the limit as x goes to 7 of x squared. I would never simplify things like that in a million years, but it's going to come in handy down the not too distant road, this property. And we'll see that later. This, of course, would equal out to the same number. Not going to go through it step by step. Okay, what does this say? This says that if we take the limit as x goes to c of f of x plus or minus g of x, you can also write that as the limit as x goes to c of f of x plus or minus, doesn't matter if you add or subtract here, the limit as x goes to c of g of x, meaning we can either take the sum of the two functions and then take the limit, or take the limit of each individual part and then add or subtract them. Okay, what does all this amount to? Well, in numbers, what that means is if you have something like the limit as x goes to, let's go with 5, of 3x squared minus 9x. Well, that's the same as just plugging in the 5 or taking each individual limit. And you'd have the limit as x goes to 5 of 3x squared minus the limit as x goes to 5 of 9x. So it doesn't matter which way you do it, you'll get the same exact answer. And if you plug 5 into this, you'll get 5 squared is 25 times 3 is 75, minus 9 times 5, plugging it in, is 45. That gives you 30. If you split it up, you'll get the same exact answer. 5 squared is 25 times 3 is 75, minus 5 plugged into there is 45, which equals 30. Point being is it doesn't matter how you do it. This limit property, if you've got the limit of products, you can just take the limit of each individual each individual function, and multiply those limits together. So you can either take the limit of the product or the product of the limits. Not so bad. And again, I don't use many of these properties. I just plug the numbers in. That's what I do. But these are formal limit properties that are good to see just in case, again, your teacher goes through them. So what is this about? This would be if you have like the limit as x goes to, let's go with, I don't know, 3x times 2x plus 1. Let's take the limit as x goes to 2. This would be the same as the limit as x goes to 2 of 3x times the limit as x goes to 2 of 2x plus 1. Again, how do I solve this problem? I'm just going to plug 2 into the darn thing. That's what I'm going to do. But whether you plug 2 into this or plug 2 into this and then that and then multiply them, you're going to get the same answer. That's what this property says. This will come in handy again down the road. For now, we'll just leave it at that. I'm not going to keep simplifying them, just going over these properties. This one is the same as that. It basically says if you have the division of two functions, you're taking the limit as x goes to c of f of x over g of x, you guessed it, that's the same as taking the limit as x goes to c of f of x and dividing it by the limit as x goes to c of g of x. Now that's provided that g of x does not equal 0. If it does, we got a problem. If g of x, and I should say if the limit as x goes to c of g of x equals 0. So that's, here, I'll tuck that in, the limit as x goes to c of g of x. That's some tiny typing right there, tiny writing. Okay, so with numbers, this would be like saying the limit as x goes to c of x squared over x plus 5. And let's make that as x goes to 0. That's the same as, well, we don't have a problem plugging 0 into here, right? And because of that, we can go ahead and split this up. That's the same as the limit as x goes to 0 of x squared over the limit as x goes to 0 of x plus 5. You'll get the same answer. Whether you plug it in here and get 0 or plug it in here, you'll get 0. That's it. Okay, this one, very much the same. This is the same as, and this actually comes in handy later on as a property. This is the same as the limit as x goes to c of f of x, all of it raised to the a, as long as a is some constant. That's it. So let me show you one like this. Let's say that you've got the limit as x goes to negative 3 of x plus 5 squared. That is going to be the same as the limit as x goes to negative 3 of x plus 5. We take that answer and then we square the whole gosh darn thing. That is the same darn thing. And no matter which way you do it, you're going to plug in negative 3, you'll get 2 squared. Here, you plug in negative 3, you get 2. And then you square it. Either way, you get 4. Right? So it's all backed up by this direct substitution. Again, only if your professor's going all formal should you be going over this stuff. The limit as x goes to c of a polynomial. All that is just going to be the polynomial evaluated at x equal to c. Okay, so what is that all about? Well, if you got some polynomial, let's say you got the limit as x goes to 10 of 3x squared minus 5x plus 7. That's going to be equal to, we've seen it before, plugging 10 directly in there. I'm not even going to simplify this. I'm just going to show you can just plug it in. So if you got a polynomial, throw the number right in there. We're good. Not bad. Of course, if you wanted to use this rule right here, you could split it into, a number minus another limit plus another. Ugh, not for me. All right, we got one more and then some trig functions that go into this. This one's actually pretty important for all you people taking advanced calculus classes in high school. Now, we've got f of g of x. That is the same as f of the limit as x goes to c of g of x. So if you've got the limit as x goes to 5, let's do the square root of x squared plus 3. That's going to be the same as the limit as x goes to 5 of x squared plus 3, that's the inner function, and then you're going to take the square root of the whole thing. It's a lot like this property right here. So you do the inner limit and then take the actual composed function of that. Again, Only go over this stuff if you're expected to do it formally. Otherwise, plug and chug. I got a little more for you. These are actually pretty important and pretty simple. If you have trig functions, you can just plug values into them. Since sine of x just keeps on going and going and going, it doesn't stop. We can just plug c right in. So if I've got the limit as x goes to c of sine of x, that's equal to sine of c. Right? The function, no matter where we are on it, we can approach an x value. We'll get the y value that is there at c. Cosine of x is the same thing. You can just plug this number right into it. As long as all of these c values are within the domains, the proper x values that give you points on tangent, cotangent, secant, and cosecant, the same thing goes with these trig functions. You can plug in c. So if it was a number like, let's say, pi over 2, which is not in the domain of tangent of x, we could not use this property. The limit as x goes to c of cotangent x is cotan c. The limit as x goes to c of secant x, secant of c, which is kind of confusing. It looks like occurs. I don't know. Anyway, cosecant of x, the limit as x goes to c of it, is cosecant of c. So specifically with numbers, if you get the limit as x goes to pi over 3 of sine of x, that is just equal to the sine of pi over 3, and you best be knowing your unit circle. The sine of pi over 3 is equal to the square root of 3 over 2. The limit as x goes to pi over 4 of cotangent of x. Pi over 4 is in this domain. This is the same as cosine of pi over 4 all over sine of pi over 4, and that will give you root 2 over 2 over root 2 over 2, which is the same number divided by itself, is 1. Trig functions, you can plug them in. The moral of the story here, peeps, despite all those limit properties, you can plug in values into limits. As long as at the point and surrounding it, you can approach it, we're good with plugging in numbers. All right, we'll end this video here. That's for you formal peeps out there that need this. I hope it was helpful.